Okay, so first thing, make sure you download MSIM7, MultiSIM7. Okay, that will be a very good uh, to do a look like the real lab. And on Wednesday and Thursday, Mr. Tai will be helping you. If you get a problem to installation, and also teach you how to using that MultiSIM 7 to do your job. So the first thing today, I try to go to the last test. Test number 2, and try to give you the right or correct answer. Okay? And that will be helping you to keep that. Whenever you get a review for the job, just open that and try go over and over. Make sure you know how to do what to do. Okay, for the test number 2, the first number, basically, they given to you the register and asking for the value. Okay, and the right answer for number 1, A or B or C or D?
C.
C, that's correct. That will be C. Okay, that's correct answer. And the next one, they say resistor so measure for 190 ohm with the meter. And the question is it in the tolerance or out of tolerance or faulty? Which one?
A, within tolerance.
That will be answer will be A. Okay, make sure you recorded the answer. Okay, so basically that will be display the true waveform on the oscilloscope. And they want to know which one will be leading or lagging. Okay, number 3, answer will be
D.
D.
perfect. That will be D. They say A wave B lead A by 90 degrees. The thing A B will be coming to a 90 degree before A, so they lead it. And also, another way, they can say wave A lagging B by 90 degrees, same thing. Okay, that we already get through one time. And now with the number 4 answer.
B.
What answer for number 4?
I had B.
Yeah, That's the
B.
correct. That's the correct answer. If you get any question, okay, just let me know. Or you don't know how come they get the answer B. Otherwise, I think you could be okay. Okay, on this circuitry here, okay, they want to know output voltage. What the output voltage? Number 5.
B.
Yeah, you're doing good.
Can you explain how B?
Okay, B, that means 9.3, right? B means
It's the Zener voltage minus the voltage drop from base to emitter.
okay, so you get the Zener will be 10 volt. Okay, so you get right here is 20. And they're supposed to be 20 up here, but they're not. Zener will be break down. So that's why you get only 10. Okay, only 10 volt in here, and basically you get a 0.7 for the transistor. Okay, so just take 10 minus 0.7, you get 9.3.
Got it. Thank you.
You're welcome. Same circuit. Okay, and they know what the current IE. Let's see, this is number 6.
A.
Hey, very good. That is the right answer. How come you get A?
You take your emitter voltage divided by your emitter resistor.
That means you divide by 50 ohm.
Yes, sir. 9.3 divided by 15.
Okay. Get it. Same circuit. They want the current through 680 ohm. That
C.
number 7 will be
C.
C. Correct.
I also got C.
That's correct. C. This is just a very, very basic problem. Technician, when you look into that, you're able to do very simple calculation. Sometimes in the field, they not require calculation. However, they can ask in the way how to get the answer. Number 8. Current cannot flow through the route. True.
C.
C.
I got C.
Virtual route. Otherwise, in the inverting amplifier, current will be go to the route. Okay, but they go to the virtual route, they cannot go to the route. Okay, for the circuit here, what the name? Easy one.
A.
Hey. I said if you not quite understand, go ahead and ask, okay? that will be non-inverting amplifier. And they want to know what is the gain of this circuitry number 10.
C.
Perfect. That will be C. The gain will be equal 1 plus R1 over R2. That means 1 plus 3K divided to 150. And the answer will be C. And then they want to calculate the V out. 11.
C.
11 will be C, right?
Yes, sir.
C.
You take the voltage input time to the gate. They want to know the current go through the 150 ohm. That will be bit 12.
A.
Yeah, you get everything correct. That means you take the 20 millivolt divide 150 ohm, right? That's what you get the current.
Yes.
Okay. For this circuitry, they want to know the secondary voltage, number 13.
I got A.
A, correct. Basically, you take 120 times 1 divided to 5. Okay, for this circuit, the name,
C.
this number 14.
Half wave rectifier.
Right, C. That's what I want. Every time you're looking into that, you can answer right away. So you can get into the point. What we want to training for you. Okay. Okay, on that one. For circuit cell, they given a 12 VRMS in the secondary. And they want to convert into the VP. Okay, number 15 will be
I got C.
C. Perfect. These are I say very simple thing you must know right away. Okay, so basically they get a 12 volt RMS and you want to calculate the V peak. V peak equal VRMS divide 0.707. Okay, they want to calculate the V out peak. Let's see, this number 16.
I got A.
A, correct. Okay. For this circuit show, what type?
Full wave
Mr.
rectifier.
Bam, can you go back to number 16 again, please?
Okay, 16 here, right.
The answer A.
Right,
Could you go over, please?
16. What
Yeah.
the formula? Now you have to know what the formula to calculate the V out.
Um,
What the formula?
Vn minus 1.4.
Mm.
You take the V secondary, right?
mhm.
Minus 1.4.
So we have to divide 110 by 0.7 and then
They already know what the V secondary. You say C means 17. V peak.
I think she wants you to write it down so she can copy it and study it.
Thank you.
So I'm already telling you, V out.
17 divided 1.4. Okay, thank you.
Là V
No, not divide.
Oh,
subtract.
subtract. Subtract, thank you.
It's the two voltage drops across the two conducting
Yeah.
diodes.
Okay, this one you don't know, you quit.
full wave rectifier A.
17 will be A.
17, yeah.
Full wave rectified. Okay, now what is the total peak secondary voltage? Number
B.
18 will be B, right?
Yes, sir.
You take 110, okay, time 1 divide 4, but you must converting to peak,
VP.
okay, V peak, okay, input will be IMS. Okay, find the peak voltage across each half secondary voltage. Number 19.
I got C.
Yes.
Perfect. C. Find the peak voltage of V out, number 20.
I got D, none of the above.
The correct answer will be
A.
D.
D.
That means after you're doing calculation, you didn't see any matching A or B or C.
Because you're missing the voltage drop across the diode?
Yeah.
Right.
If you don't know, just select none of the above. "21.
I got C.
C, correct.
Yes.
Do you know what the name for 50 microfarad?
Nail polish.
What the name for that? capacitor.
Bypass.
Now, if you say bypass, that means no output. They short you out.
Oh, coupling.
Coupling.
No coupling. When you say coupling, you have to say DC coupling, AC coupling. But that capacitor is not the coupling. It's not the bypass.
Filter capacitor.
That will be filter.
I said filter capacitor.
Okay?
And that's what you're reducing the ripple from the output?
Exactly. The name of that filter will be of that capacitor is filter. Okay, you understand the output here, they want 10 volt, whatever voltage DC. Okay, 10 volt for example. However, on the top, they can get ripple. That means the noise. Okay, so that capacitor here, that they call a filter. Okay, so that's why you can get a ripple. If you want a small ripple, then the capacitor value will be small or bigger.
The bigger the capacitor, the less noise.
Exactly. Okay. Otherwise, the output, they can get a very big ripple. That is not good. A big noise. Okay. Let's see, 21. 22. Big secondary voltage. That's what we're looking for. Okay. 22 will be
I got A.
perfect.
I agree.
A. Look like you're doing very good, man.
Thank you.
Yeah. Can be a very good technician. Okay.
Thank
23. Find the peak of the V out. 23.
B.
Got
Perfect.
B.
Perfect. Yeah. B. Okay, try to review and try to make sure you know how come we get B. If you still cannot confusing, can get through that, get Zoom with me. We'll help you out.
Thank you.
Yeah. 24.
C.
What most like caused the problem? Let's see. DMM
C.
measure indicate faulty. Okay. So normally when you can see you get a 10 volt here and you get a 10 volt here. Cannot caught by RC.
The transistor's open.
Right, exactly. Transistor not working. So that's why they open here. No current can be flowing down through the transistor. So that's why no voltage drop across the RC. And that's why you get 10 volt VCC and the VC you still get the same 10 volt. The answer will be C. Okay, so almost done. Last one. Okay, 25. Same thing, right?
Yes.
You can,
Transistor.
if you're doing a calculation, then maybe this voltage okay, but I don't care. You get a 8.26 volt here, and you get the same voltage here, okay? So look like the transistor is not working. So the answer will be C again.
Mr. Fan,
Yeah,
can you go back to number 7?
number 7. Okay, turn on. Let's see, 7, 21, 14, 9, 8, 9, 7 here.
I got C, but then how do you get C? Somebody said it was 9.3.
Okay, let's see what they said. They say current through 680 ohm. Okay, easy. What voltage you get here?
20, and then 10 on the other side.
Is it right?
Yeah,
Yes.
So I will be equal.
20 minus 10 divided by 680, right?
Ah.
Okay. Okay, that's fine. I thought somebody said it was 9.3 divided by something else. Okay, thank you.
No, that was a previous one. That was the current across the 15 ohm resistor.
Oh, okay, okay. All right. Thank you.
Or that, I'm sorry, that was the emitter current that we were calculating.
Right,
there.
right. Okay.
Welcome. Any question about this test? Okay, so if you don't have any question on test number 2, then now I will be go to what will be asking you on the test tomorrow. Okay, first thing, I want you to do that calculation for me. Go ahead and do it. If you not download it, go ahead and download from Handout. So that will be, okay, that will be a voltage divider. So what I'm saying, if you don't have a this handout, go to the handout, electronic, download this file.
This file.
So I will be helping you. So tomorrow for any calculation, you can get through it. And you already know, okay, VV equal 10 times R joule. Okay. Who get the answer, let me know. I can put it in so the other people can copy it.
3.19 volt.
Yes.
So who get the VBB?
3.19 volt.
Okay.
3.19.
One get the 3.19. Is it right or wrong?
I
That's
don't
good.
know.
I agree.
Okay. That means right at this point, 3.19. And this will be 0.7. So VA, VB minus make sure you doing your calculation, okay? Otherwise, tomorrow you cannot do it. I think tomorrow we'll be doing in a limit time, 3 minutes, 8 questions only. And after the VE, you can easy to calculate IE, VE, IE. And after you get IA, you can get IB. IA 1 blood beta. Then you can get the IC. Beta time IB. Okay? Then the next will be VC. VCC minus IC time RC. And the last one, VCA. VC minus VA. So if you know how to do it, tomorrow at least you can get 7 questions done. The thing is, transistor get a different type of bias, but this is a very, very common, very, very general. Everything gets so the program must know how to do it. When you think you're ready, then we can go to the next. That was a very short review. Okay, any question? Okay, if it's not, we go to next. Okay, this is the same thing. However, they will be B and B. So if you know, you're looking into the circuitry, you know that will be F meter. That will be collector. That will be base. So VB or BB the same word. Okay? Okay, minus 12 time R joule.
Negative 1.7 volts.
Okay, you said you get minus 1.7, right?
1.7.
Yeah, 1.74.
Close enough, yes.
1.74.
Correct.
Okay. And now they want VE.
Negative 2.44.
I say negative 1.04.
Okay. VE equal VBB. B or BB, same thing. Okay. And they will be plus.
Right, because it's reverse biased here.
0.7.
So the voltage drop goes the other way?
The thing is that will be a minus 174. Okay, and that one will be less negative than
Right.
one. So that's
Right.
why you have to plus 0.7. So basically, they will be equal minus 1.1. 0.4.
0. Yes.
Since it is a PNP transistor, that's why plus.
Yeah,
Okay.
either NPN or PNP. This is general the bias. Then we have to know how to do calculation. So that's why I stop.
Hey, Mr. Pham, is that because like since the arrow is pointing in, the current is flowing into the base from the emitter, correct?
Yeah, we already know the current for a transistor NPN, right? IE go this way.
Right.
IC leaving. IB leaving.
And the emitter's grounded, but that's still positive compared to VCC.
The other one negative. So that
Right.
current still flowing.
Right.
Ground means 0. However, the other one, they can be 0.7.
Yeah, I have a question.
Yeah,
If VCC was positive 12 volt,
no,
then we should have subtracted 0.7. Is that correct?
hold on. Cannot be positive. If they positive, the circuitry will minor different. Not this circuit.
If it was positive, it'd be an NPN, not a PNP.
Oh, PNP also, but the different. We'll see. However, what I'm saying for this way, for PNP, then the voltage must be negative. And after you get the VE, then you either calculate the IE.
1.8 milliamps?
IE basically, they will be equal VE divide RE. Okay? However, you understand the VE is negative,
But current cannot be negative.
cannot be negative. Okay, now I can tell you a little more.
Oh shit, that's negative?
Current never be negative. I telling you one more time here. IE, the current will flow this way. Okay, so this is a 0 volt. This will be minus 0.4, 1.4. So if you want to calculate the IE, you have to take the different potential. 0, minus 1.04 divide RE. So that's why you can see minus, now no more negative. So that's why current cannot be negative. And the same thing, when you get IE, you can get IB.
35.2 microamps?
Yeah, whatever. 1 plus beta. Okay, IC same thing. Beta times IB. Okay. And if you calculate the BC, then you still the same formula.
Negative 8.832 volts.
EC will be VE. VE minus VC. You already know VE. You already know VC. Then you can calculate the VEC. Make sure nothing for free, okay? You have to spend time to study in order to be a technician.
And Mr. Pham, can I ask a question?
Go ahead.
VE and VC are both negatives, but VEC is positive?
And
Yes.
if you're doing a calculate the VE, you get a negative, right? And the VC, that's still a negative.
Right.
So you take your VE minus VC. Then you can see the negative are not depending on which one is higher.
Right. Okay. So I got 7.792 for my VEC here.
That will
That's just
be,
that's just the difference in voltages
Yeah,
from VE to
that
VC.
will be a minus, right? Minus or
No,
plus.
mine is a positive here, unless I did something wrong.
The thing is, I said you take VE minus VC. VE we already know minus 1.04. Okay. And someone calculated minus 7.7 for VEC.
So Mr. Pham, VEC should be a negative number.
Right.
So why am I getting it as a positive? What am I doing wrong here then? I'm getting the right value. I'm just getting it as a positive. Well, so when I subtract negative 8.832 from negative 1.04, I'm getting positive 7.792.
Okay, let's see what you get VC.
What am I doing? I must just be doing something wrong.
No, what you get VC?
VC, I have VC is negative 8.832.
VCC minus IC. IC, right?
Yes, sir.
That will be minus 12. Minus IC will be 1.8K. Time RC will be 1.8 and IC you doing calculation. Okay. What IC you get? IC equal beta time IB.
I'm sorry. You're looking.
You know what I think he should do? He should say negative 12 plus a negative whatever, and that'll give you the negative number. Because if you go minus times minus is a plus, but minus times plus is a minus.
I must have just done it wrong on the calculator.
Yeah, that's what it is.
I got the right value. It came out positive.
Yeah.
Okay. Okay, thank you.
Now, try this one. As you can see, VCC now will be positive, but the circuitry will be look like different. You understand F meter now will be here. That will be collector, and that will be the base.
Still PNP though.
Same PNP, but a different configuration.
Right.
So go ahead and try to complete that one. That one you will be see on the 10. VB the same thing. 10 times 2.2 divide 10 plus 2.2. So if you get the VB, let me know what value.
So you say for VB, it's same formula R2 divided by R1 plus R2 times VEE. Am I right?
Exactly.
6.875 volts.
10 times R2, R1 in this case. They have to be multiplied by this register here.
Right.
So if you not pay attention, you can get a wrong answer. And you get a VB wrong, you get everything wrong. So what VB you get?
I got 6.875 volts.
Okay, one gets 6.8. If you not get the same, let me know. Otherwise, you guys can get everything wrong. I'm not doing calculations, don't do it.
I also got 6.87.
Perfect. So that is correct. How can we get VA? You understand VE mean here. Okay. And from here, VB to the round, you get 6.875 volt. The difference here will be 0.7. Okay. So
Yeah.
VE will be VB.
Plus.
Perfect.
Can you explain one more time how we got VE?
From here, VB. Okay. Right here. To the round, you already know. And from here to the round, the difference between the E and B is 0.7. So that's why you have to take your VB adding to VE. Adding to 0.7, sorry. And the current flowing here, IA. How can we calculate the IA?
VE divided by RE?
Come on.
Huh? No?
You can see IE flowing from VEE through the admitter. So the current have to be the different voltage, okay, between VEE
Oh, yeah.
minus, then you can divide to RE,
Oh, yeah.
okay?
Yep. What was I thinking?
That is the harder part. After you get the IE, then more easier. IB, IE, 1 plus beta, and IC equal IB times beta. And now how come you calculate VC?
VC is IC times RC, or yeah, IC times RC.
Perfect. VC means right here. This is the round. Okay? And you get current IC. So basically, RC times IC. And the last VEC, VE minus VC. I hope the test tomorrow you're able to get A. On all those
Are you,
calculations, you get 14 points. Yeah.
are you going to change the values of the resistor or no?
All right. We see.
Okay.
If you can do it, a question less than 3 minutes, you'll be okay. This time we can review it, but next time, no review and you have to do it. I try to give it to you until you can see it, you know, right away how to do to solving the problem. That is the purpose. Okay, so after that one, any question, just let me know. But you must be review it, must be redo it. Guarantee you can do it in a question less than 3 minutes. Let's see, IE, you take 10 minus VE and divide to RE. Who get the answer?
2.425 milliamps.
2.425.
Divided by, okay, divided by 151.
And who, oh no, that's the VE. Sorry, what VE you get?
7.575 volts.
7.75, right?
7.575.
Okay, 575. IA will be equal VE minus VE. Oh, sorry, VB. Okay, VB, VEE mean 10 volt. 7.575 divide 1K. So I don't know whatever you get.
IE? IE is 2.425 milliamps.
2.425.
Yes, sir.
Okay.
IB is 16 microamps.
15
16 microamps, yes.
microamp.
IC is 2.4 milliamps.
Okay.
VC is 5.28 volts.
Okay. That one.
VEC is 2.295 volts.
Okay. Okay, now, before we stop on that review, I can tell you a few things next will be asking you. Okay, what VL?
First of all, Zener is not in breakdown. Or it is in breakdown.
V out is 5.1 volts.
Perfect. They will be 5.1 volt.
Because the Zener's in breakdown, right, Mr. Sam?
Breakdown.
The cathode is positive in respect to the anode.
Right.
That means any voltage here greater than 5.1, they will be 5.1. Okay. Next one. If Zener open, what VL?
30 volts.
Divider. Put the divider.
0.7.
Perfect.
Ah.
Perfect. If they open, that means you don't have a Zener here.
15 volt.
Okay. So you want VL just a voltage divider. Right?
Mm-hmm.
Equal 30 times 1K divide 2K.
Right.
Okay.
Okay.
So now if the Zener not open,
That's number 3, right, Mr. Pham?
right? What I load. That means they asking current flow here.
So it would be that 5.1 divided by the 1K, wouldn't it?
Perfect.
$5.1 milliampere I load.
Yep, easy. Okay, and the last question on that one, I1 IL. I load if in open.
So would that be the 15 volts divided by the 1K?
Yeah.
Right? Yeah, that's all you have left.
You try to trick us, huh, Mr. Pham?
Ha 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 ha. A little tricky.
He got me.
Come on, Adam, he didn't get you.
That thing I want to really understand. Will be no problem if you understand how they work it. Okay, last question on this circuitry. Make sure you guys already take the note, otherwise I erase it.
Okay, this number 5 coming up, right?
Yeah, that one more thing I want to add.
Okay, number 5.
Now, I change that to minus 30 volt. What we out?
A negative 0.
First of all, the circuit is can we say the circuit is not in breakdown because it's a minus voltage and minus 30 is less than 5.1?
Negative 0.7.
Minus 15 volt.
Ha! Come on.
It's 0.7.
Right. This is a minus
Has to be negative 0.7.
30 volt, right?
Right.
So
So
the
it's not in breakdown.
diode did not break down. They working like normal.
Normal.
So normal means you substitute positive, negative, and the value will be 0.7. So that's why.
Tricky, Mr. Pham.
That's what I said. I asking you to really understand.
Mhm.
You can do like I do. You okay?
Hey, Mr. Pham, that's because like minus 30 on the number line is left of 0 and 5.1 is right of 0, which means 5.1 is still higher than the minus 30, which means the diode is not in breakdown.
No, not breakdown. They're just working like normal.
Yeah.
When the anode higher than the cathode. And you substitute by the battery.
And it's the same voltage drop. It's 0.7. So if you start with 0 on your positive side, then it's negative 0.7. That's your voltage drop.
Right, that's the same 0.7. However, you have to pay attention on the polarity. We already telling you, if they break down and review this thing here. That VG. If they break down, then you have to substitute by the positive, negative. The value here will be plus. That will be negative VG. However, if they not break down, they working normal. Then they will be look like positive here, negative here, negative, positive, 0.7 for
Work like
silicon
normal.
diode.
Work like normal.
Right, it's normal. However, pay attention on the pointing negative.
Hey, Mr. Pham,
Yeah.
can you just do one last thing? Can you just give one, before you leave, one baby example of how to do the Zener when you're using AC with the positive and negative half cycle?
No, not now.
Okay, next time.
But yeah, next time. The thing is we still get few things. Okay, so
Okay,
here, right?
all right.
Okay. So I need to unshare that one. Okay, just give me a minute. Okay, now I'm talking about quickly about MSIM7, giving you the idea. Okay, double click on MSIM7. Okay, multi-SIM7. Let's see, I try again.
I think you gotta wait.
What you mean?
Hey, Mr. Pham, I think when you click on it, don't you have to wait for a little while and then it'll do whatever it's got to do? Click on it again.
I don't know why. Okay,
Just wait for a second.
can be done in the network, man. What do you mean on the network? I try to see if we can get through it. I never seen this happen before. Okay, I stop share and I try to run it without sharing. No more instant of the program can be run in the network. I'm not in the network.
Did you have any other MSIM open, or if you have one open, you cannot open up another one?
But the thing, I didn't see any open here.
Oh, okay.
That's the problem. Oh. I don't understand why they're not.
Do you have restriction to open up zip files?
No, the thing is that normally, you know, I already installed on mine. I'm still working on that. Let's see, I try to go to that thing. Let's see. Let's see, how come? Project manager. Project. Hey, Sam. Hello, Sam.
Yes, sir.
You have any sample?
Yeah, I can run my MSIM on my side. You want me to go ahead and share the screen?
Okay.
Okay, I'm going to share my screen.
Yeah.
Okay, so all right, so I'm going to open up now. I already have mine downloaded. It's on my taskbar here. So I had to do just click open that, and it would go through, and it would come up something with the little signal, this message, but that's okay. Just click OK, and this should open up. Okay, and then you can do like we can do the same simulation of the one that Mr. Pham have, which is this circuit from the sample test minute ago. Say if I were to look at the schematic for number one, okay, so I can so I look at the schematic number one, for example, and so therefore, okay, so let me see if I can make it a little bit bigger. Okay. So schematic number one would be something similar to this. So therefore, I look at the parts I need. So this is like a transistor. So a transistor, and then it has this label on the side here. And so you have to do is just click on one of them. Now this one look like a transistor. Transistor, it would be somewhere for this one right here. It's this. Now you can click on this one here to bring up this component selection. Or you can click on the transistor, which is this one here. Let me see, transistor, which is this one. Now, normally if you click it and it will pops up something in that little square like this, and you double click on it, and then they put it right on the top of the screen for you, okay? So example, this one is a NPN. So we can choose the ones at NPN, which is this. You can put this cursor on it, and then it would show you what that part is. And then so that's what you want, the NPN. You click it, and now you want to do it, just put on your work table here. Okay, so that is your NPN. Next thing, you need all the resistors. So you got 1, 2, 3, 4 resistor. Okay, so now you had resistor. Resistor would be considered as a basic component, and as you can see, it's disappeared. But when you click it one more time, it would, like I said, sometimes it just comes out like this. Double click it, and then it will place on top for you. So next thing you want to do is just click on the resistor, which is that symbol here, and you just have to do just put 1 and the next one. Oops, next one, and then next one, and then next one. And now, and then all you have to do, okay, so next thing we need a VCC. So we need a power supply. Power supply is this one here, which is represent DC. And then we need some common. So we need a common supply, common at the bottom. Okay, so common there, and we need one more.
Yeah.
Yes, sir.
I make it bigger.
Okay, yeah, I've just placed it here, and now I'm going to click on this one here to enlarge it. Let me see, go ahead, enlarge the screen. Okay. All right, so now I have to do, okay, so enlarge it a little bit more. Okay. Okay, can everybody see that?
Yep.
Yeah.
Okay, now that we have all the parts started of all the parts here on this screen, I have to do is click on that part, say R1, and then we need to turn it this way. So you want to do is highlight that, and this little square opens up, and you can go up to Edit menu, and then you can right here you can do a flip horizontal or flip vertical, 90 degree clockwise turn or counterclockwise, or if you remember all the shortcut key, you can use the shortcut key. So I'm going to use the clockwise turn. Okay, now it's look like exactly what this one on the schematic.
I
So
think is it on your right mouse or something?
You can do a right click on it, or you can go, like I said, you click on this one and just go to edit and just choose this, go to edit, and then come down here and say turn it clockwise, or you can right click it and then you can also choose that say clockwise. Okay, so right click and then clockwise. Okay, so now you have exactly the component turning the right way. Now you want to do is just now we want to do it, just put it close to where we need, where all the parts is at before we start connecting the circuit. Okay, so all right, so this one up a little bit, and so we can make it a little bit bigger. Okay, so now I can make it a little bit. Okay, so okay, now I have to scroll this one over and this one over. Now that we have all the parts in place, now we have to do is just change the value or change the label. Okay, so if you want to change the value, you want to do just click on the number, and then you can change the value. So this one, double click it, and then it bring up here, say resistant value. We want that to be 10 kilo ohms. So 10, and then you have to choose your unit over here. So make sure it's kilo ohm. And then if your label is something else, you can click on the label and change it. But in this case, we only need R1 and it's 10K. So, and then once you have that done, click OK, and you can see it change automatically. Okay, now and then do the same thing on here. And then you want to do is 4.7 here. So 4.7K. Click OK. Now we look at this one right here. It's going to be 1 kilo ohm and RC. And so I can click on that, and then okay, so this is 1 kilo ohm, and then the label is RC. So right here, reference ID, we're gonna put it RC for change it to RC label. And same thing with this one here, RE is going to be 470 ohm. So double click on this one. So we're going to be 470, type it in, and it's going to be ohm. So we have to do change this unit down to ohm. And then we change the label to RE and click OK. Now we have all the label in place, and the VCC is going to be 10 volts. So therefore we come in here, we change this to 10 volt, and label is going to be VCC. Okay, so now we have exactly where, now we can't change this beta, but this one is a virtual. We just showing you an example of how to do that circuit here. This one has a different beta value, but we can't change it to this exact one. So we just have to do it, just working with this example. Now that we have that in place, now we have to do is just connect the wire. So what we want to do is come to the lead of the component. And then once that has that marking there, and you left click on it once, and then go to the lead of the other one and click it, and that's what connect the wire. All right. So therefore, let me go ahead and do all of them, and it goes here, It goes here, and this one from here goes here. This one goes here, here and here, and here and here. Just same, same, almost similar to what you did in PSpice. Okay, so therefore, now we have that in place. Now we have exactly, now, and then once you're ready, you can start inputting your meter. Now in this case, we're going to look at, say, we can put like a display, look like we can put our oscilloscope, let me see, we can put on a meter. So that's like your DMM. So you turn on your DMM and then come in here and turn this power on. And we're gonna measure all DC values. So we're gonna make sure this is VAC, we want VDC. So therefore we click on this button to change it to DC. Okay, now we have DC. And then once we have that set, now we wanna do is, okay, the high one is this will represent this one. That will represent this top one right here. So we're going to be connecting that into a circuit. So if we measure VBB somewhere here, and then the common, it will be the low, which is this one right here. So it's going to be coming down here. So it's going to be this one, the third one down. Okay, and that's what represent a common, and we connect it to common. So anywhere that where the common is at, we can put it here or we can put it over here. Doesn't matter, but I'm going to use it. I'm going to put it. Oops. I'm going to put it right here. Okay, so now we have exactly at VBB. Now I'm going to just come up here and turn on my circuit. I can simulate it, or I could put F5 to simulate the circuit. So right now I'm turning it on, and then it will tell me exactly how much voltage. As you can see, it's 3.04. Okay, so, and then from your calculation from earlier, let me see, did I write that the answer down? No, I did not write down the answer. So that's how you do, and then that's what you could put, and then that's what your value say. That would say, for example, VBB here, it's going to be, say, 3.04 volt. All right. For example, I'm just going through, just filling out that sheet. Okay, the next one is VE. So VE is in the emitter. So it's going to be at the emitter here. So now I disconnect so turn off this circuit in order to disconnect your wire here. Okay, so disconnect. Now you want to do is connect it to the VE. VE is right here. Okay, and then we turn on the simulation to simulate to collect our data. Okay, so right here, VE is telling me exactly 2.23 volt. All right. Okay, so the next one, now we have to do it, just turn off a simulation. Okay, moving to the next one. Next one, they want to make, so I'm going to just go ahead and just measure getting all the voltage first. So next one, I look at VC. Okay, so now I disconnect that, put the C would be here. All right, so the C, and then turn on your simulation. And the value would show up here. Now I can turn it off right away. This doesn't disappear. So I come over here and just type in my value. So 5.29 volt. Okay. So now they want measure VCE. So therefore, okay, so now I have to do is disconnect this one. Okay, so the C is going to be the high side. So there is the C, and the low side is supposed to be on the E. Okay, I need to move this one a little bit away from that. Okay, and that's put at the E here. All right, and then turn on the simulation, and that will give you the value of VCE. Okay, so that would be, so now I have to do just type that in, equal to 3.06 volt. All right. Now, next thing you want to do is measure IE. Okay, so IE, now first thing we want to do is just come into a meter here. We want to change it to the current. Current is, it's on the top line of the button right here. So I need DC current. So therefore, in order to get to the top selection, you want to push shift first and then choose the DC. So this is DC current. As you can see, amp DC, all right? So now we have to do is just disconnect all these, my connection. Okay, so my current would be, the current would be using the bottom here. Look like the bottom is current. There's a letter I for current. Okay, so now we're gonna look at IE. So IE would be down here. So I have to break the circuit and then put my high side on this side, and then the low, which is the middle, and then that should be on the other, go to the other side there. Okay, and now I have to do just turn on my simulation to get my data. Okay, so now I can turn it off and come in here and type in my value, 4.75 milliamp. See, it has a little MA, so milliamp, all right? So now that one is done. So now I have to do is just disconnect this. Okay, now I have to do is just go to the next one. Now I have to reconnect this wire here to make the full connection. Okay, next one is IB. So IB would be here. All right, so IB, so therefore the high side would be go here and the low side would be go here. And then once that is connected, turn on your simulation. Okay, it is going to say 0.047 milliamps. So if you convert that into microamps, we'll be moving the decimal places to 3 places to the right. So 1, 2, 3, it'd be 47 microamp. So therefore, this one equal to 47 microamp. All right. So now we turn it off, disconnect the wire. Now what we want to do is reconnect the base. Now we need to find IC. So IC, so C is here. Disconnect that. Okay, put the low side right on this side, and then the common to this side. And then we turn on our simulation. Okay, it gives you approximately equal to 4.7 milliamp. Okay. And now we turn that one back off. Okay, so that's why from here, you can practice all these other one with different circuit. Like you can go into the next circuit. You can do like this one here, the PNP, or like I said, PNP would be this one right here. Let me see if I put it on here. Yeah, so the PNP would be this one, this symbol here. Yes. Okay.
So basically, this is a real lab. That means if you know how to using the meter, that's a real meter, exactly the meter in the lab. Also, we'll be using the oscilloscope, okay, on the generator. That will be the real.
Oscilloscope, we're going to be here. So this is oscilloscope.
Anything will be answered to you on Wednesday. And you will be get more assignment on MCM 7. Okay? If you know how to working on this thing, that means you're able to do the lab no problem.
I'm sorry. Now we can download the multi-sim.
Yeah, that's what I said.
I think he said, yeah, you can go into here and you probably can go into handout and then scroll down to the bottom. Let me see, MSIM simulation. This one is a PDF. So that's a PDF. Now,
handout.
Very bottom.
Very bottom. Okay, very bottom right here, the zip file.
Yeah.
And also the other one, PDF, means instruction.
Yeah.
What to do.
Yeah. We never have a multi-sim before. Just recently.
Yeah, on this semester until now.
Yeah, thank you.
Let me see.
The thing is, beside also the simulation, but the more theory. On multi-sim, also simulation, but more practical.
Okay, so you can be able to do that and then collect your data so you can compare, you can compare whatever your what you calculate to whatever the circuit produced, because this one will take in consideration of all the tolerance and all that. And this is like the real thing. This one, like if you do calculation, that is like the theoretical value or your ideal value. We don't live in ideal. We live in the world with application where things run differently. And so this circuit, so this virtual simulation works really good. And like Mr. Pham said, you know, this one is more like a real world type of simulation. Okay. All right.
Okay, so we'll see you guys tomorrow.
Yeah,
Okay.
thank you very much.
All right. Have a good one, everyone.
Thank you.
You're welcome.
Bye-bye.